Hello, class 12 ML Aggarwal students. Today I am going to start a new chapter and I am actually doing the chapter determinants, and we are left with just Cramer's rule and finding the inverse and all that in the determinants. I'll continue that video, but today I want to start with the chapter continuity and differentiability. Okay, continuity and differentiability. First of all, we'll learn about continuity, and then later on in the videos we'll talk about differentiability. Now, what is continuity? Now, you don't need to learn the definition, but you should know what is continuity. Like normally you speak continuous, okay, something that is continuous, or something that you, suppose if I tell you that I want you to draw a line from this end of the board to that end of the board without picking up the pen or the pencil or whatever you have. So you know it's very easy to draw, right? And if you continue, it will continue going. Now look at this line. Does this line have any break? No, no break. We are not stopping anywhere, right? We started from this point, say A, and we ended at that point B without picking up a pen. Now this is the basic understanding or the basic knowledge of continuity, where you can draw a line or a curve or anything you want to draw without picking up your pen. So if you can do that, then that type of a line or that type of a curve is continuous. But if you cannot do that, where you have to stop, suppose you have to go this way, okay, and then another point is somewhere else, suppose say starting from here. So now what happens, if these are two lines, what happens, there is a break. If you draw two axes x and y, then you can see that this line went till here, it stopped here, then there is a break, and then it's continuing. Okay, so I'll show you an example how we can find that a line or a function is continuous. By now all of you know what is a function. Okay, and you all have the knowledge of limits because you all have studied it in class 11. If you don't know what is limits, then you can watch my class 11 videos on limits. So let us start. Let's say if I give you a function, let's say f of x, give you a simple function, say x plus 2. This is a function. Now in class 9, in class 10 or whatever class you have learned it, you might have learned it like this: y is equal to x plus 2. What happens? The y is a dependent variable. This y is a dependent variable and this x is an independent variable. What does that mean? That means that this y depends. Dependent means it depends on the values of x. So whatever value of x you take, you will get values of y that will be more than 2 of whatever values of x you are going to get. So this y is actually equal to f of x. This is a function of x. So f of x is the y coordinate and these x values are the x coordinate. Simple logic. So if you start plotting this, in class 9 you all have plotted it. Let's say x is equal to 0 you start with, then y is equal to 2. Then you start with x is equal to 1, then next you take 1, then y is equal to, what is that, 3. Then x is equal to 2, then y is equal to, what's that, 4. 2 and 2, 4. Then you can take negatives also. X equal to minus 1, then y is equal to what? Minus 1 plus 2 is just 1. Then x is equal to minus 2. Then what do you get? Minus 2, then y is minus 2 plus 2, 0. Right? Look at this. now when you plot this, okay, now when you start plotting this, so this is the same thing, okay. Again, I don't have to show you. Now when you start plotting this, let's put it in a box. You'll have done this actually in your class 9 and all. You'll have done this. So this is x and this is y. Okay, that is 0, y is 2, then x is 1, then y is 3. Then after that, x is 2, y is 4. Look, if you put 2 over here, 2 plus 2, 4. Then x is minus 1, going to the negative also. Then y is 1. Okay, x is minus 2. Then y is 0. So actually you don't have to take many points. You can just take a few of them. And then now we start drawing the graph. Okay, now let's draw the graph of this. So just let's make the graph. So that's your positive x-axis. This is your origin. That's your positive y-axis. And the negative y-axis you can write as y dash. And the negative x-axis you can write as x dash. Now when x is 0, then y is, let's write the points. See, in the positive direction for y-axis you have maximum of 4. Okay, so start plotting 1, 2, 3, 4, and you can put an extra one, doesn't matter. 2, 3, 4 and 5. Then for x-axis, in the positive is just till 2, in the negative is just till minus 2. So 1, 2, put another one to be safe actually. Then minus 1, minus 2 and minus 3. Okay, now let's start plotting. So when x is 0, then y is 2. So this is my first point, say A. Okay, mark, put this as A, put this as B, put this as C, put this as D, put this as E. So these are your points. You have written A, B, C, D over here. You don't have to plot points over there. Just write A, B, C, D. They will understand. 1, comma 3. Then 1 in the x-axis, 3 in the y-axis. So 3 this way, 1 this way. This point is your B point. Then next is what? Oh, sorry, I wrote x equal to 2. So 2 comma 4, 2 comma 4. So from here like this, and from here x-axis 2, y-axis 4. So this is your point C. Don't put the point because there is no need because the point is already here. Then minus 1 comma 1. So x-axis minus 1, y-axis 1. So over here this is D, x-axis 1 and minus 1. Then x-axis minus 2 and y-axis 0. X-axis minus 2 and y-axis 0. This is E. Now when you see, you start with say any point over here, you start and you see you don't need to lift your pen. Yeah, even if you go this direction also you don't need to lift your pen, and then you can make the arrow. These arrows you have to lift your pen. So what is the meaning of this? That means this function is continuous. Okay, there is no way where you have to lift your pen, okay, to make these lines. Alright, even if you get fraction also, doesn't matter, still you will get values. Okay, that means this function is continuous for all the x belonging to real number. Okay, so you take any x, you will get points that will come in a straight line, and you can draw this line. So this function, this type of a function is a straight line. So if I put a square over here, then this function becomes something else. Okay, it's not a straight line anymore. You can draw that. So let's try and draw this and understand what happens. Now let's plot this. Okay, let's plot this. Then you will understand how a curve also is continuous. Okay, so if I put x equal to 0, then what do I get? 0 square is 0, that's just 2. Then y is equal to 2. Then I put x equal to 1, then I get y is equal to 3 because 1 square is 1. If I put x is equal to 2, then y I get what? 2 2s are 4, 5, 6. Y I got a 6. When I put x is equal to minus 1, then what do I get? Y as minus 1 whole square is 1 only, and that is 3. So if I put x is equal to minus 2, then what do I get? Minus 2 whole square is 4, and that is 2. Y is equal to 6. Okay, if you want, you can put more points. Put this only in the box. You need to make another one. Now let's start plotting. Okay, now look at this. So this is the x-axis, this is your y-axis. Now when my x is 0, this is origin. Okay, so let's start writing actually all the points. In the y-axis we have till positive 6. So 1, 2, 3, 4, 5, 6, right till 7. 1, 2, 3, sorry. 7, 6, 5, 4, 3, 2, 1. Okay. Then positive till 2. 1, 2, right till 3. 1, 2, 3. Negative also same thing I took. Minus 1, minus 2 and minus 3 for safety. Now let's start plotting. X0, Y2. X is 0 but Y is 2. Here is the first point. This is A, this is B, C, D and E. When X is 1, then Y is 3. When X is 1, then Y is 3. Look at this. X is 1, Y is 3. B. Next. When X is 2, then Y is 6. So when X is 2, then Y is 6. This is C. Okay. When X is minus 1, then Y is 3. When X is minus 1, then Y is 3. Here. So that's C. This one is D. Then when X is minus 2, then Y is 6. Again, X is minus 2, then Y is 6. So this is E. Now if you see, you plot this, it's going through this point, going through here. See, you don't need, don't put arrow. You do, this was the point, yeah, went through this way. So see, I am not having to pick up my pen. I am not having to pick up my pen. So that is a curve, isn't it? So you see, that is the main thing of continuity. So this function is also continuous for any value that belongs to real number, for any x that belongs to real number. Now this is just understanding, okay, just for you to understand what continuity means or what is continuous. How do you understand whether something is continuous or not? So when you can plot a graph without picking up your pencil or your pen, that means that function or that type of a graph or that type of an equation or anything, whatever you want to call it, is continuous. Now this is just understanding. There is mathematics to it which you have to learn or which you have to understand. Okay, when you have to prove that a function is continuous. Now if you notice that a function can approach from the left hand side, from the negative side, and it can also approach from the positive side to the center. Okay, from the left hand side it can approach here, and from the positive side also it can approach there. Okay, so now we'll understand how we will say that a function is continuous or discontinuous. Suppose if I give you an example of a function that will be discontinuous, that's given in the book actually. If I give you this example, okay, no problem. f of x is equal to 2x square minus 5x plus 2 whole thing divided by x minus 2. Now many of you all will say, sir, we'll split this, we'll get rid of the x minus 2 and then we can easily get the function, but it's okay. But when you have this type of a function, can you see at the point where you're not getting, which value of x will make it discontinuous? At x equal to 2. As you put 2 over here, you're getting divided by 0 and you're not getting any value. So it's discontinuous at x equal to 2. So understood, when you draw the graph, you will not be able to find an answer when you put x equal to 2. So that's the breaking point of this function, because you cannot have a 0 down here. Okay, as you put a 2 over here, you get a denominator as 0 and you cannot divide by 0, so you will never find the answer. So that point is discontinuous. So now we'll understand the logic, how to solve the questions. Okay. Now everything is given over here. I'll write the definition. A function. I'll write the definition. You can write the definition also. Although you will not need the definition, all you need is to do the mathematics. So according to the definition, a function f is said to be a function. Okay, this is the definition of function left continuous. This is the definition of left continuous. Okay. Now I told you that a function can approach from the left hand side and a function can approach from the right hand side also. So we need to define the function from the left hand side, it's continuous, and also from the right hand side it has to be continuous. Okay. So definition, this is the definition. Okay, for left continuous. Okay, definition for left continuous means continuous from the left hand side. Okay, so a function f, don't write now, once I have finished writing and I explain, then you write. A function f is said to be, left continuous I forget the spelling actually. Anyways, it's okay. Left continuous or continuous from the left, or continuous, INUOUS, continuous from the left. You can write any one. Okay, left continuous or continuous from the left. Okay, at x is equal to c, at any point x equal to c, any point you can take any number. Okay, at x equal to c, if and only if IFF, when you write IFF, that means if and only if. This means if and only if. Okay, IFF in mathematics it means if and only if. So a function is said to be left continuous or continuous from the left at x equal to c if and only if these things happen. First one, f of c exists. Okay, f of c exists means, what does that mean? That means you cannot have divide by 0, like just now I showed you that function. So f of c should exist means you should have an answer for f of c. Okay, you cannot have math error, that's not the answer. Okay, next, limit x tends to c approaching from the negative side. This c, the negative on the top of c means approaching from the negative side, but when you have it written as like this kind, it means minus c. Okay, this does not mean minus c, you have to put the value of c only. Okay, this means approaching from the left hand side, the graph is approaching from the left hand side. Limit of f of x, x approaching from the left hand side, okay, also exists. This also has to exist. This also, you should have a value for this also. Okay, and the third part, this is only called left continuous. This is not the whole of continuous. This is continuous from the left hand side, when the graph is coming from the left hand side. Like when you draw this, when you're drawing like this kind, the graph is coming from the left hand side. Okay, so we are understanding about this part, left continuous. Okay, and limit of x tends to c negative f of x, f of c it will be. Okay, f of c. Now f of x, it's okay. F of x is equal to f of c. Otherwise there won't be any differentiation. So what are the 3 points for a function to be left continuous? F of c must exist. Suppose if you put f of 1, it should not come infinity or something like that. Okay, it should exist like a number, a real number or something like that. Now when you find limit is written like this in the textbook. Those of you who want to write like that, go ahead. Those of you who want to write LIM this way, you can write that. Okay, you won't, all these things will not, you won't get 1 mark also cut. Okay, so you don't have to worry about it. Then the limit of c approaching from the negative side should also exist for the function, and limit of c f of x should be equal to c. Okay, so if you do a question on this, if I give you the same function, like a small one, if I give you say x squared plus 3, and if I tell you that find whether the function is continuous at x equal to 3, say, check whether this function is continuous at x equal to 3. So your 3 is the c actually. Now your first step is what? Just put f of 3 and check it out. That is 3 3s are 9 plus 3, 9, 10, 11, 12. First part is over, correct? Second part is what? To check whether limit of x tends to c negative f of x exists or not. So start with it. Limit of x tends to 3 negative f of x is equal to, you have to put a 3 over here. Okay, I told you 3 on the head negative means not minus 3. Okay, it's just 3 whole square plus 3, that is also 12. Okay, and the third part is you have to show that these two are equal to each other. These two are equal to each other. So see, look at this, f of c, this is f of c, correct? And this is limit of f of x. Yeah, so limit of x tends to 3 negative f of x is equal to f of 3. So that means the limit exists. Okay, so it is continuous. That means it is, we are talking about continuous, not limit exists. So this means that it is left continuous. It is continuous from the left hand side. So when you draw the graph, when it's up this, when this curve is approaching from the left hand side, you will not have to pick up your pen. That's what it means. Okay, that's it. That's all. Okay, this is your left continuous. Let's go on to the right continuous. Now we'll think about the graph approaching from the right hand side and then making this into a proper curve. Okay, so next is right continuous. I'm not rubbing off everything, okay, because I need it. I have actually rubbed off more or less everything. Okay, no problem. RIGHT. Right continuous. Okay. A function f is said to be right continuous. Same things you will have to write, right continuous or continuous. Right, I didn't even write that one. Right continuous, don't write the second part. So right continuous at x equal to c if and only if these three things happen. First one, f of c exists. F of c exists, that is a c. F of c exists. Second part, limit of x tends to c positive, means approaching from the right hand side. F of x exists. F of x exists. So we are talking about actually what? We are talking about the two parts of the graph. We haven't got to the whole continuity. In the first part we spoke about the left continuous, and in the second part we are talking about the right side. From the right side it's continuous. Okay, but what about the whole thing then? What about the whole thing? Then when are we going to speak about the whole thing? I think you will talk about it. Not now. Let's write this first. So limit of x tends to c plus f of x is equal to f of c. So you see, if you notice, so these three things you'll have to prove. These three things you can try with the same function that I gave you at x equal to any number you want. You can also put a fraction also, doesn't matter. You still get it continuous. Okay. Now, in the previous part, in the previous definition, it was left continuous. In the second definition, this is 2, write this as 2. Okay, that was 1, that, and this is 2. Okay, write that one as 1. In the definition 1, I was showing about left continuous, and in the definition 2, I am showing about right continuous. Now, what does this mean? That means I have gone from the left also and I have gone from the right also. That means for this function to be continuous, both the left and the right should be equal. So, when the left side continuous is equal to the right side continuous, when this left side is equal to the right side, then the whole function is continuous. That's a simple thing. Okay. Hence, now what you can write this. Hence a function. Understand? Okay. Hence a function is continuous. Now you just have to write just continuous. Is continuous. Hence the function is continuous at x equal to c if there is a double F, yes, if and only if, I double F, if and only if, don't put like this in capital, it's not the way to write, you write like this, if and only if both left continuous, how they wrote it, if and only if both left as well as right, if and only if hence a function is continuous at x equal to c if and only if both left, if and only if it is, I'll write my own, it is both left and right continuous and limit of x tends to c negative, f of x is equal to limit of x tends to c positive, f of x for the same function, talking about the same function, is equal to f of c. So this is basically what you need to write down. Okay, those things that you have written is very easy to understand, very easy to solve it. Okay, this is when the whole function is continuous. So the function that I have given you, f of x is equals to x squared plus 3, has somewhat of a graph like this. So when limit of x tends to c, any c that you have chosen, I had chosen 3 that time, you can choose 5. So in both ways, when you get in the left side, when you get all 3 parts correct, in the right side when you get all 3 parts correct, and then when you match the third parts, is becoming equal to the function when you put c over there, then you understand that this function or this graph, this type of a equation is continuous in both ways. Okay, so this shows that a function is continuous at x equal to c, that some point is given to you. Okay, now a function fails to be continuous at x equal to c for the following reasons. Now this is we have spoken about continuity. I made you understand how you can show that a function is continuous. If you can try for that, you can try. So if I am to show you in the short way, then look, limit of x tends to, I had taken 3 negative and I had got f of x which was equal to 3 3s are 9, 9, 10, 11, 12. Now if you take limit of x tends to 3 positive, okay, still you will have to take a 3, that is 12. And when you put f of 3, okay, that is also equal to 12. Now you can see this negative approaching, positive side approaching, all are equal to each other, right? So this function is continuous. So we have spoken about continuity. You have any doubts on it, you can let me know. You know how to let me know. Okay. Now we are going to talk about discontinuity. Not much of it because I don't want to pressurize you too much with this in the first day or first class only. So little by little we'll understand it and clear the concept up. Okay, basic questions are very easy. Okay, once the concept is clear, questions are very easy. So what happens when does a function fail to be continuous? So this is the third point, right? A function fails to be continuous for the following reasons. Is it written for? Continuous for a function fails to be continuous at x equal to c. Don't forget, at x equal to c, a function fails to be continuous at x equal to c for the following reasons. For the following following reasons, REASONS. I have to write like this, like kids don't remember the spelling sometimes. Okay, for the following reason. First reason is very simple. Okay, first reason is given that f is not defined at x equal to c. So f, right, small f is not defined at x equal to c, which means function does not exist at x equal to c. Okay, like that function 2x square minus 5x plus 3 or something like that, it was divided by x minus 2. So when you take 2, the function does not exist. So this type of a function does not exist. When you write this as f of x, as you write 2, the function does not exist. What is the second limit? What is the second reason? Limit of x does not exist. Okay. Second part has two parts split up. Limit of x tends to c. Limit of x tends to c. F of x does not exist. So you get any one of this, okay? You can say the function is not continuous. It doesn't matter that you got the first one, you have to check the second one. Not like that. As you get the first one does not exist, the function is not continuous at that point, only at that point. If you put 3 over here, the function is continuous, okay? If you put only when you put 2, the function is discontinuous. We are talking about at a particular point. Don't get confused. We are always writing at x equal to c. So when this as a whole this function does not exist, when you just put a c, okay, because whether you put a c approaching from the negative side or you put a c approaching from the positive side, you are actually putting just c. You're just putting the positive value. You're not putting negative values. Okay, because that if you write like this, limit of x tends to 2 minus f of x, and you put, say, whatever the numerators, I'm not writing, minus 2 if you put, that's wrong. You cannot put minus 2 because it's approaching from the left hand side. It's not a negative 2. You have to put a positive 2 only, okay? So don't make that mistake. Oh, I rubbed out the function also. 2x square minus 5x plus 3 divided by x minus 2. Okay, so when this as a whole does not exist, that means if I put limit of x tends to 2, f of x doesn't no existence. Okay, there's no existence for this type of a function. So what happens? Then for this there are two parts. One part is either limit of x tends to c negative, f of x does not exist. Okay. And limit of x tends to c positive, f of x does not exist. Okay, so these two things will happen when this happens. Okay, and or both does not exist but not equal. Okay, there is a little bit of the third part also. Third part is very simple. Okay, it's very simple. Okay, both of these two parts will not exist. Of course, both these parts will not exist, because this part will not exist, this part will also not exist. So both, now you write both limit of x tends to c negative f of x does not exist. This limit of this and limit of x tends to c positive f of x does not exist. Does not exist. Or there can be one more part. Just write or, that's not a fourth part, okay? Or limit of x tends to c negative f of x and limit of x tends to c positive f of x exists. They do exist, but are not equal to each other. But are not equal to each other. So a function will not be continuous if limit of x tends to c negative f of x is not equal to limit of x tends to c positive f of x. So if it's not equal, then it's not continuous. Okay, there is a break. Alright. Now, this is the second part when it's not going to exist. This is the second, these are the points for the second part where they will not exist. Okay, these are the rules where the function will not be continuous. Now there is another one, that is a 3. Okay, these are all actually small rules that you will see in the function when you are solving. No, so you will understand, okay, this is happening, so it's not continuous. You are not supposed to do from there anymore. You're just supposed to write it's not continuous. So these are the points or important things that you should understand. Okay, so first one I have written, second one I have written, second one has these 3 parts. Okay, make sure you write it properly. I'm writing the third rule, how to know that a function is not continuous. Okay, so you will have to continue only under this heading only. I'm writing the rules when the function will not be continuous as it is given in the Aggarwal book. Very nicely given. It's all the same. Okay. Third part is limit of x tends to c f of x exists. Okay, it does exist. Exists, but limit of x tends to c f of x is not equal to f of c. So the limit of the function is not equal to the function, then the function is again not continuous. So this is another important box. You don't have to learn all of them. The box that I showed you, this limit of x tends to c, first part you learn, just understand it. Just understand. Okay. So this is your third part. Now the fourth part. Fourth part again has 2 parts under it. The first part is very simple. Limit of x tends to c negative f of x exists. It does exist, but by now you have understood. Limit of x tends to c negative f of x is not equal to f of c. So this is the fourth one. This is why the function will be discontinuous. Second part with the positive approaching one, c plus f of x exists. Okay, but limit of x tends to c plus f of x is not equal to f of c. It's not equal in that point. So you can mark both of them in the box. So you know which parts when you will say that it is it's not continuous. When exists but f of c does not exist, or this is not equal to say, we say that f has a removable discontinuity. Okay. Now I want you to just write this as the fourth point. That's called removable discontinuity. Tinuity. Okay. If I ever go for a spelling competition, I'll fail. I know. Anyways, when this is what when we call a removable discontinuity, when limit of x tends to c, f of x exists. Okay, no problem, it does exist. Okay, but two things will happen. One, f of c does not exist. F of c does not exist, or there is a or. You can put a or when limit of this exists, but either f of c does not exist or limit of x tends to c, f of x is not equal to f of c. So when this is existing but f of c is not existing, okay, and this is also not equal or this is also not equal, then we say that f has a removable discontinuity. Okay, removable discontinuity. Otherwise, we say it is non-removable discontinuity. Okay, that means the discontinuity can be removed or it cannot be removed. Okay, so removable discontinuity, this is okay. That is enough for continuity for class 12 students. Okay, nothing else you must know. Okay, I hope you have marked. You will write these things in your notebook and understand it once again. Go through it, understand it. I cannot go through it once again because I have rubbed them off. Sorry about that. So I want you students, to go through this continuity, okay, and understand when a function is discontinuous, because continuity is very easy. Only the discontinuity part you have to understand, okay. And then in the next video we will start with the questions, okay, and I'll tell you how many questions are there. For this exercise, there are 25 questions, exercise 5.1. We will start with the first question in the next video, okay. So take as much help as possible from my channel, Math is Possible. See you next time.